This week we will be discussing table creation and management. The names of our tables and columns have certain rules we must follow when we name them. Table and column names can contain a maximum of 128 characters and really shouldn't have any spaces in them. They must begin with a letter. They can contain numbers, underscores, and the pound sign, number sign. They must be unique to the scope. What that means is we can't have two tables with the same name in the same database, and we can't have two columns with the same name in the same table. And we can't use reserved words for names of tables or columns. So things like select, from, insert, those can't be used. When we define our columns, we must enclose the column list in parentheses. We have to specify a data type for each column, and each table can have a maximum of 1024 columns. This is really a lot of columns, and that would be kind of ridiculous to have a table with that many columns, but that's the maximum. So let's recap our data types before we start creating some tables. I'm going to move to the next slide where we discuss them a little bit more in depth. So for numbers, we have exact numbers. We have different types of ints: big ints, regular ints, small ints, and tiny ints. So a big int translates to a long in programming, so that's an int 64. An int is a regular int, that's an int 32. A small int is a short, or an int 16. And a tiny int is a byte. We have money and small money, which represent exact numbers for money, and decimal and numeric, which allow us to specify how many decimal places we have. So precision is how many total digits the number can hold. That's what the P stands for. And scale is how many numbers to the right of the decimal. And float and real are for floating point numbers. Then we have character data types. So we have a char, or a char, that holds a specific number of characters, and always that number of characters. We have a varchar, or varchar, and that will hold a variable number of characters up to the amount we give it. And text will hold text. That is a deprecated data type, so you shouldn't use it for new development. And then we have the Unicode equivalents of all of those data types. You should only use the Unicode equivalents if you need to store Unicode characters. Dates and times. Date just holds dates. Date time 2, small date time. All of these hold date and time with varying ranges for date and time. If you need just a normal range of date and times, sometime in the last century or so, you would use a date time. Date time offset is a date and time, but it is time zone aware. And then time is just for time. Then other data types we have bit. That is SQL's equivalent of a Boolean. It is literally a bit. It is 0 or 1, true or false. Unique identifier, that's a GUID. Binary and var binary, those are going to hold binary data, like images. And then XML is for holding XML data. Other special things we need to talk about with creating our tables. Tables can have what are called identity columns. This is SQL Server's version of an auto-increment or auto-number field. These are most often used for primary keys. You can have any type of integer for your data type in an identity, and you have to specify where you start and how many to increment by. So if a column is defined as an identity 1, 1, it means start at 1 and every new row increment by 1. So let's go ahead and create a new table. switch to my correct Northwind Traders database and make sure that I am connected here. So let's pretend we don't have an employees table in our database and that we are going to design a new one. Create a table to hold employee information. So let's think about, what do we need to store in this table? We need the employee ID. I'm going to make a list and then we're going to create our tables. Create our create table statement. So we need an employee ID. We're going to need the first name. Might be a good idea to have the middle name, last name, address, say line 1, address line 2, city, state. This is a US only company. We can do this. City, state, and zip code. So we're going to pretend this is a US only company. What else might we need to store for an employee? Well, we should probably have their date of birth, their hire date, their termination date. Let's make it easy and have a field that tells us if they're an active employee. So let's call that is active. And let's include their salary in here. So these are the columns we're going to put in our table. I'm going to start with create table. Then we have to give it a name. So we have an employees table in this database, so I'm going to call it employees new. Okay. So open parenthesis at the top, close parenthesis at the bottom. For each column, we have to specify a data type. So employee ID is going to be our primary key, which means we should pick an identity, which means we have to pick some sort of integer. We could go with an int. If this is a smaller company, we could go with a small int, because we're not going to go over 32,000 records probably. So I'm going to define this as a small int identity. We could start at 100 and increment by 1. We could start at 1 and increment by 1. We could pick a bigger data type and start at maybe 1,000 or 10,000. However you want your employee IDs to look, however big of a number you want to use. So then after our column is complete, we put a comma and move on to the next one. So first name, this should be a varchar of some sort. Usually for names, somewhere around 20 to 30 characters is usually long enough. I'm going to go with 30 just to be on the safe side. You could probably even go up to 50 for any of the name columns, but anything beyond that is generally a little bit overkill. You really don't need to allocate space, extra space for a column if you wouldn't ever use it. So these are going to be the same. I'm going to do 30 for all of these. Address line 1. Some addresses could be pretty long, so let's do a varchar 50. Again, this is text, so it should be a varchar. Same here. City is going to be a varchar, and probably not as long as our addresses, so let's make that a 30. State. Now, we probably want to store the abbreviation for state, in which case it's going to be 2 digits or 2 characters all the time. So we should really pick a char data type for this. So, char 2, always 2. Zip code. I'm going to make this a varchar because we might want to store a 9-digit zip code. But a 9-digit zip code also has a dash, so this would be a varchar 10. This way we could store it as 5, or we could store it as the 5 plus 4. Date of birth, simply a date. We don't really need to store the time a person was born, not in our employee database. Maybe if we had a healthcare database we would. Same with hire date, termination date, date. Is active, this is going to be a bit, true or false. And salary, this is going to be either a numeric or decimal. Remember, those data types are interchangeable. I'm going to make it a numeric. Now, if I think about salary, we could potentially have employees making over $1 million. Probably wouldn't be realistic to go much higher than that. So 1 million is 7 digits. And then we need to include 2 decimal places, so that's 9. If we want to be extra safe, we could add 1 more and call it a numeric 10, 2. 2 is for 2 digits in the decimals. Now all of our columns have data types. But before we go ahead and create this table, we need to talk about constraints. Constraints are rules that are used to enforce business rules, practices, or policies. They also ensure accuracy and integrity of data. So the constraint types we have are a primary key constraint. That tells us which column or columns uniquely identifies each record in the table. You cannot put a null value in any primary key column, and the data must be unique. So if we have our primary key, let's go ahead and create that. So we decided employee ID is our primary key. There's 2 ways we can create that. And we can name our constraints if we want as well. It's a really good idea to name our constraints. Otherwise, the server is going to give us some sort of default name. If we violate a constraint when we are adding or modifying data, it will throw an error message to tell us which constraint is violated. If we have a useful name for our constraints, it's really easy to understand what happened. If we let the server name them, it's not quite as easy to troubleshoot. So when we can create our constraints, we could create it at the column level or at the table level. And I'm going to demonstrate how we do both of those. So I'm going to copy this and show both options. This is going to be the table level constraints. Put these side by side so we can see them as we go. This is going to be my column level constraints. So if I want a primary key, I could just say simply primary key, but then the server will name the key for me. That's not such a good idea. We should have a good name for a primary key. So I do constraint. I'm going to move this to a new line so we can read it. Then we say the name. So I like to name my primary key starting with PK for primary key, underscore the name of the table. So employees new. So if I violate this constraint, it will tell me violation of constraint PK employees new. It's pretty self-explanatory when you see that error message as to what column is the problem. Okay? So that's how I do it at the table or the column level. To do it at the table level, after my last column I add a comma and I would say constraint. Again, I got to give it a name, PK employees new. And I'm going to call this 2 so that you can see both of them. So employees new 2. It is a primary key constraint. And at the table level, I have to tell it what column or columns this refers to. So this is the employee ID. If I have a composite primary key, so a primary key that has more than one column, I cannot create it at the column level. I have to create it at the table level. So I would do employee ID, let's just say it was also last name. That would create it on both columns. But in this case, it's really just my employee ID, so I'm going to leave that. Primary key is defined. You can create a table without a primary key, but it's not a good idea to do that. So, foreign keys, next constraint. That makes sure that a value that we enter must already exist somewhere else. In this table, we don't have a good reason to have a foreign key. We'll set up another table that references this afterwards, and we'll set up our foreign key. Unique constraint, or unique key. This is very similar to a foreign key, but with a couple differences. So our primary key, you can't have duplicates and you can't have nulls, only one per table. The unique constraint still can't have duplicates. You can have one null value and it still enforces that everything is unique. So in our table, we don't really have a good unique fit. If we added SSN, which we could do, so let's add SSN. So that is going to be a char 11. So we have all the digits plus 2 dashes. And I am going to name this constraint. Uniques are actually keys, unique constraints, so I'm going to call it UK for unique key. It's going to be employees new SSN. That's how I'm going to name this one. And then I'm going to say it's unique. I'm going to add my column again. So in this case, to add it, after my last item in my table, I'm going to add another constraint. So UK employees new to SSN, unique, and again I have to say what column it is, SSN. Next constraint is a check constraint. This enforces certain values for a column. When we add new records or update existing records, they must meet those conditions. So this could be based on a value. It could be based on an expression. It could be based on a character. The only thing is that we can't refer to other tables. We could refer to other columns in the same table, but we can't reference other tables. So if we look at our columns, there's a couple of them that could have some check constraints. So we can't terminate someone before they're hired. So I'm going to add a constraint. Check, I usually do CK for check. Employees new, move this to a new line. So this is the termination date. We have a check constraint on. It is a check, and then this is a condition that gets checked. So I can say termination date greater than or equal to, I suppose you could be terminated on your first day, hire date. So your termination date has to occur on or after your hire date. Another one we could have a check constraint for is our salary. So constraint, CK employees new, salary. It's a check. People should not be allowed to have negative salaries. We could have 0 for a salary if they are an intern, if they're unpaid, but we shouldn't allow negative salaries. So check is that salary is greater than or equal to 0. We can do the same thing over here at the table level. So I do constraint CK employees new to termination date. This is a check again. Termination date greater than or equal to hire date. Same thing with the salary one. Again, this is a check. Salary greater than or equal to 0. Okay, next constraint. Not null. It's a special type of check constraint. Basically, says that the column can't allow null values. This can only be created at the column level. So if I want something to not allow null values, I will specify not null. So employee ID, since it's our primary key, it already won't allow null values. We could specify it. We don't have to. So let's go through and figure out what can't be null. Well, if we have foreign employees, they might not have SSNs. They have green cards or visas. They won't have an SSN. First name, though, we should always have a first name. So after the column data type, we can say not null. Always have a first name. Always have a last name. We may not have an address initially when we put an employee in, so we probably shouldn't require that. We should have their date of birth, though. And we might not be entirely sure when they're going to start, so we might not want to put in a hire date. Is active. So this is one we want to talk about. This is a bit. This is true or false. Something that is true or false should never allow null values. So when you have bits, you always want to specify not null because you don't want to check for true, false, or null. Salary, we might not know their salary initially, so we wouldn't include that there. And over here, we're going to have the same things because you can't do these at the table level. They still have to be specified at the column level. Okay. Last type of constraint is a default value. So default values can be assigned to a column. This will put in the default value if we try to put a null in the column when we add or modify data. One thing to note is that this is not retroactive. So if we add this after there is data in the column, it will not go back and apply that default value to any nulls. So if we look at our tables, the only column that would make sense to have a default value is active. So we don't allow a null in it. If somebody tries to put a null in it, we should put a default value in. So by default, if you're putting a new record into an employee table, it's probably because they're new and they're active. So I'm going to say default 0. Oh, sorry, default 1, true, is active. So that's the default value that will get added. You could do these at the table level after the fact. It usually doesn't really make a whole lot of sense to do that though. So I'm just going to put it at the column level here too. Default values also generally don't get constraint names because it tells you you can't violate a default value. So let's go ahead and create our new tables. So I'm going to create both of them. Apparently I can't reference another column here. So let's just say that is greater than let's just get rid of this one for now. I'll have to look into that one. Okay. So we can create that one. We can create that one. When I go to my database, if I refresh it, I have employees new, and I have employees new too. So these two tables should be identical. So when I expand them, I see my data types. I have a primary key indicated here. I see my null or not null. Null just indicates that it's allowed to have a null. I could specify that here. By default, it assumes that it allows null values, so that's really not necessary. If I look at my keys column here, I see my primary key and I see an upside down key, which is my unique key constraint. That's why I called it a key, because it exists in our keys and it functions similarly to our primary keys and our foreign keys internally to the server. We also have our constraints. We have our check constraint for the salary. And then this is the default value for this is active field. So you'll notice that it gave it a default name, however that SQL Server generates these. And we're going to do the same thing on employees new too. So let's say now we also want to track job titles for a person, and we want to be able to track the history of them. So we're going to create a new table for this. So create table, employee jobs. So we need the employee ID. We need a job ID. Let's add a job code. So this is going to be a short description of it. And a title and the description of the job. Okay, so job ID. This is going to be our primary key. So it's going to be, I'm going to make this a small int. Again, it's an identity. Start at 1 and increment by 1. I'm going to add my primary key constraint. Employee ID. So this is going to be the employee ID from the employees table. So I'm going to use the same data type here. If I don't, when I create my foreign key, I'm going to have some problems. Job code, that's a char 4. Title, it's going to be a varchar, let's make this 30. And description, let's make this could be really long. And I'm really not sure how long it could be. Maybe it might be thousands of characters long. So when I have something that is a varchar that I really might not have a good upper limit for, I can define it as a varchar max. That just says that it's a varchar data type. I can have unlimited characters for it. So employee ID, that's a foreign key. That comes from my employees table. So I have to define it as a foreign key. So I'm going to do this at the table level and the column level for you. I will move this one as well. So there's our column level and our table level. So this is going to be a constraint. It is a foreign key, so FK. I like to name these with both the name of the table that we're on and the table that we're referencing. So this is employee jobs, and the other table involved is employees new. This is a foreign key. I say references, employees new, employee ID. So the table and the column. And this is just IntelliSense. So I can do Control-Shift-R. That should refresh my IntelliSense. And now no more squiggles. So that's how I do my foreign key at the column level. I can also do it here. Constraint FK employee jobs 2. Again, this is going to reference employees new. I'll just go to 2. It is a foreign key. Now the column that is the foreign key is the employee ID. Preferences, employees new 2, employee ID. Whether you do it at the table level or the column level is really up to personal preference. I like to list them at the table level because I think it looks cleaner up with my columns. It really doesn't matter though. So I'm going to create these tables. To refresh. So if I look at these, there's employees new and employee jobs. So I've got job ID, that's my primary key. Employee ID, that's my foreign key. So it puts a silver key here for that. I get a gold key for a primary key. It doesn't show me my unique key in here upside down, it's just in the keys, which is a little strange to me, but that's how it does it. So that's creating our tables and our constraints. So if we need to change a table after the fact, we can use the alter table command. We can use alter table add to add columns or constraints after the fact. We can use alter table alter to change a column or constraint. And we can use alter table drop to remove a column or constraint. So let's say we don't like the salary in the employees table anymore. We want it to be in the jobs table. So we're going to track the salary with the job. Move the salary column from the employee table to the employee jobs table. So this is just the column definition. If there was data in this table, we would need to do a lot more, which we will talk about in class. So the first thing I would do would be to alter table employee jobs, and I'm going to add the salary. I'm just going to copy what we had up here. And I'm also going to add the constraint. Check employee jobs salary, salary greater than 0. So when we alter the table, we don't have parentheses, we just do the commas. So if I run that, and I refresh my employee jobs table, I will see my salary, and I will see my constraint. So now I need to alter the employees new table. Alter table employees new, drop column, salary. When I do this, I should actually receive an error message. It says my check constraint is dependent on this column. So what I actually need to do before I drop the column is to drop the check constraint. So this is one of those places where it's nice to have named it, because I can literally copy this and say alter table employees new, drop constraint, let's check constraint. With alter table commands, you have to do them one at a time. They cannot be stacked like we did with our add here. We added 2 items. We can't drop 2 items at the same time. We have to drop them one at a time. So if I remove the check constraint, now I can remove the salary column. So if I refresh employees new, I'll see that those columns are gone. So let's say we need to also change an existing value. Say for some reason the city column is too small. We need to make it bigger. So we can use alter table, alter column to change its size, its nullability, or its default value. When we change the column, though, we can't make it smaller than any of the data it contains. So if we tried to make it fit a varchar 20, but we had a column, we had a city value that was 25, it wouldn't let us do that. So if we have a number column and it already has data, we can't make it smaller. And again, adding or changing the default value does not change existing data. So let's do our alter table, employees new, alter column, city, that's the one I want to change, and I just redefine it. So I would say varchar 50. And when I refresh this, now it's a 50. Now let's also say that for whatever reason, we don't have somebody's birth date yet, but we need to put them in the system. Right now, birth date doesn't allow null values. We can also do an alter table, alter column to remove that not null. So I do alter table employees new, alter column birth date. So I have to redefine the whole column, or date of birth, sorry. It is a date time, and I'm going to say null to force it to allow null values. Now when I refresh, it allows nulls. We already dropped the column. It is permanent, so if you drop a column, you kill all of the data in that column. You don't get it back unless you go beg your DBA to restore from backup, in which case you better be armed with a lot of whatever it is they really like. Beer, candy, coffee, whatever. With dropping columns, you can't delete the last column in a table. A table has to have at least one column. But you can remove the table. So if you really don't want a table anymore, we're going to use the drop table command to remove it. Again, this is permanent. Your only option to get it back is to restore from a backup. So let's drop some tables. One thing to note with this is the order that we drop tables is important. So if I try to drop employees new, I can't drop it because there's a foreign key on employee jobs that references this table. So first I would have to drop table employee jobs, and I'll drop both of them. And then I can drop the table employees new and drop the table employees new too. So then when I refresh my database, all those tables are gone. All right. That concludes our lecture on table creation and management. When we meet next time, we will be discussing adding, modifying, and removing data. We'll see you in class.